Hello everyone, I am Rakesh, Roshan, faculty in Electrical Engineering Department of KIT Polytechnic. So today I will discuss about alternator. Alternator is also known as synchronous generator. So I will cover these topics in today's class. Introduction, a brief introduction about alternator, advantages of a stationary armature, and elementary idea about construction of alternator. So in earlier semester we have studied DC generator. So in this semester we are going to study alternator. So generator is called as a alternator. So as if we are recalling DC generator, what basically DC generator does, it converts mechanical energy into electrical energy. Same things is performed by alternator also. It also converts mechanical energy input into electrical energy. And both machines are based on Faraday's law of electromagnetic induction. As per Faraday's law of electromagnetic induction, for working of any machines, three things should be required. One is your magnetic field, another is your set of conductors or armature binding, and there must be a relative motion between them. So for working of both machine, things are similar. All three things are required. It is also required for alternator, it is also required for DC generator. So yes, so some important points regarding alternator. It is a primary source of all electrical energy we are using for our day-to-day life purposes. So as we know, so the supply we are getting for our domestic purposes as well as also for industry, that is in form of AC, and that is generated by alternator or synchronous. So that's it is also known as largest energy converter throughout the world. Yes. Earlier I was discussed between some similarities between DC generator and alternator, but one important difference between both the machines. If you are recalling the construction of DC generator, then you can recall the field binding is, in case of DC generator, field binding is placed in a stator and armature binding is placed in the rotor. But in case of alternator, things is just opposite. Your field binding is present in rotor and armature binding is placed in a stator. So what are the advantages of this type of arrangement? Of advantages of a stationary armature or rotating field? So first point, it is easier to insulate a stationary armature winding. So we can yes, as we know, working EMF or output of alternator or generator is produced in armature, and so obviously it will be work at higher voltage and higher current. So as we know, we are providing in thickness of insulation as per voltage rating. If it will operate at higher voltage, so we have to provide higher thickness of insulation. So if it will be placed in a stator, so providing insulation is easier. And also, if it will be placed in rotor, what happens if you provide such amount of thickness? So your size of rotor will be bulky and it will be inconvenient for rotation. And second advantage of this type of arrangement is it can be directly connected to the load. That means in earlier point I have said, so working output or working power is produced in your armature. So and your armature is placed on a stator. So you can connecting the leads, connecting the wire through the leads. So So this is one of the major advantage, but it is not possible. But it is not possible in case of DC generator. In case of DC generator, your armature is placed in rotor. So we are fetching power through the brush and commutator segment, and which in brush and commutator segment continuous sparking are happening there. So that's why maintenance of DC generator is more, and it's require frequent maintenance and at regular interval. So that thing not happens in case of AC generator. Your armature winding or your output is produced in a stator. And third point is permit lighter construction of rotor. Obviously your rotor is supplied by DC source, and comparatively your armature, your field required less power, and field is placed in rotor. That's why less power, so for less power your size of rotor will be lighter, and only 2 slip rings are required for the DC supply to the field winding. So, like other rotating machine, alternator has also two major parts. One is a stator, another is rotor. Your stator houses three-phase, a star-connected binding, and rotor having your DC field winding, DC field winding. So this diagram gives elementary idea about construction of alternator. So we can see this is outer construction. It is outer frame which is support a structure for your alternator. It is generally made of cast iron or silicon steel, and this is your armature core. And armature core is having slotted a structure in which your armature winding and your armature winding is a star connected, and neutral is grounded through a resistance to the earth. So what are the advantages of a star connected armature winding? Yes, this question generally asked in your laboratories, viva and interview. So so what are the major advantages? First advantage of a star connection, yes, be a design, as earlier slide I have told about the rotor, be a providing our insulation as per voltage rating. And as we know, in a star connection, phase voltage is 1 by root 3 times of line voltage. That's why in a star connection, requirement of insulation is lesser. That's why and another advantage, there are other several advantages. In a star connection, yes, there is possibility of neutral, but it is not possible in case of delta connection. So so what is the advantage of neutral? If unbalanced loading occurs in alternators, so there is circulating current flows in your armature winding, and that is suppressed through the neutral and suppressed into the ground through the neutral. And yes, also it is helpful to eliminate third harmonics. So this is the advantage of your star connected armature binding. And yes, this is your rotor. So rotor having poles adjacent, generally your adjacent poles having opposite polarities. So this is your, yes, this alternator, like induction motor we have studied, there are two types of rotor. In alternator also there are two types of rotor. One is your salient pole type, another one is your non-salient pole type. So points regarding a stator. So we have already discussed all those points. Yes, second point, built up of sheet steel lamination. Yes, it is built out of sheet steel lamination having slots in inner periphery, and all those points we have already covered. Yes, this is actual diagram of actual stator looks like this. So we can observe from here, this is slotted a structure in which your armature winding are placed. Three-phase armature winding are placed. Yes, the rotor carries a field winding which is supplied by a DC source. Yes, in AC generator or alternator, the field winding is also is energized by DC source, and the DC source is generally a small DC shunt and compound generator which is mounted on the shaft of your alternator. So rotor is, as earlier I have said, rotor is two types: salient pole type and non-salient pole type. Yes, this is the construction of our salient pole type rotor. So in silent pole type, it is also known as projected pole types. So you can observe from this diagram, poles are projected here, poles are projected here. So this type of rotor is suitable for lower speed application like hydroelectric power plant. This type, some important features of this type of rotor is its axial length is small and diameter is large. So it so is larger diameter permits accommodation of larger number of poles. So earlier I have said this type of machine is used for lower speed operation. So if, as we know, the equation of synchronous speed n is equal to 120 f by p. If so, a speed of operation or synchronous speed will be lesser. So larger diameter permits accommodation of larger number of poles. Yes, same questions here. One question arises: why it is not? Why this type of rotor cannot be used for larger speed? So answer is simple. You can observe from this diagram. Here pole is projected type and larger number of poles are placed. Here, in this diagram we have shown 4 number of poles, but generally 8, 16 and 32 number of poles are generally present in silent pole type rotor. So you can just have an idea if it will, this type of machine will be operate a higher speed operation. So obviously friction and windage losses will be more. In your house, you can observe from fan how much noise it produces, and also noise will be larger. Yes, so these are some features. Silent projecting poles are mounted on the large circular steel frame, adjacent poles having opposite polarity, that means north south, north south, and suitable for lower speed operation, generally 120 to 400 rpm. And some important features I already have discussed is a shorter axial length and larger diameter. Yes, this is non-salient pole type rotor. It is also known as a smooth cylindrical type rotor, and it is used in your high speed high speed of operation, where alternator required for higher speed of operation, like your steam power plant. In a steam power plant, generally non-salient pole, and this type of rotor is used in such which alternator, that is called your turbo alternator. So in a steam and nuclear power plant, this type of rotor is used. So in this type of rotor, a smooth cylindrical construction slot is there, in which slot are present there, and your field winding is accommodated in your slots. So it is made of a smooth solid forged steel radial cylinder having slots along the outer periphery, as we have seen in the previous diagram. So field winding are embedded. So field winding, yeah, as I've seen, field winding are placed or embedded in slots connected to the slip rings. So it is suitable for higher speed of operation. Generally, it operates at only two speeds, 1500 rpm and or 3000 rpm. If your number of poles is 4, then it will be operated at 1500 rpm. If machine having two number of poles, then it will operate at 3000 rpm. If a machine having four number of poles, so it will be operated 1500 rpm. So yes, yeah, construction of this type of rotor is robust, so it gives noiseless operations. But your silent pole type having some noisy operation. So this is basically all about the construction of alternator. Thank you. Thank you all.